Okay, so Unit 6 is our last unit. Now, well, I should say welcome back to the end of week 13. We only have 1 week left. Next week, it's a full week, so we have a lab on Tuesday. Obviously your last lab. It's going to cover the topics that I'm going to do today, or topic I'm going to do today, and then that's it. And with Unit 6, there's about 55 slides or so for this unit. I might be able to finish it next week, but no matter what I get done, I'm hoping to have some review for your final exam next week. So probably Thursday's class for sure, maybe even Wednesday's class, depending on how much of this unit we can get done by Monday. So let's get started here. Unit 6, other functional groups. All right. Oh, let me make sure I'm sharing my screen as well. Okay, good. So, in chapter 1, we did an introduction to organic chemistry. Chapter 2, we looked at alkanes. Chapter 3, alkenes and alkynes. Chapter 4 was aromatics. And then chapter 5 was petroleum chemistry, where we applied this information to petroleum. Well, there's obviously other functional groups in hydrocarbons or chemicals, and we're going to look at some of them more specifically, or more importantly, we're going to look at alcohols today, and of course we'll look at halogens as well. Your last lab is on alcohols and their properties. So we'll cover that today for sure. And then next week, maybe Monday's class, we'll do as much of the other functional groups as we can. So let's get started here with section 6.1. What about some organic halogen compounds? So organic halogen compounds are basically exactly what they sound like. They are organic compounds that contain one or more halogen. Halogen, if you can't remember from, well, we did this in chapter 1. You guys did this in chemistry 1120, even 1121. Halogens are group 17 or 7A on the periodic table. So halogens are in group, oops, 17 or 7A on your periodic table. So this includes fluorine, chlorine, bromine, or iodine. And then combined with other elements or other hydrocarbon chains, we would get an organic halogen. So when you compare alkanes to haloalkanes, haloalkanes have higher boiling points because of London dispersion forces. London dispersion you did way, way, way back in chemistry 1120. Basically, it's kind of like a slight dipole that gets formed on these molecules. And the more electrons they have, the larger the molar mass, the more London dispersion. So when you substitute, for example, a hydrogen on a carbon chain, hydrogens have 1 electron, and you add in a halogen, so something like fluorine, which has 7, chlorine, bromine have even more, you're adding to the total number of electrons. And that means you would have a higher boiling point. So something like propane compared to, let's say 2-chloropropane, the halogen one, the 2-chloropropane, would have a higher boiling point. London dispersion forces, like I said, increase with surface area. So haloalkenes have more surface area, more electrons, more importantly. And that increases the boiling point. So that would be a good multiple choice for your final exam, for example. I could give you a list of hydrocarbons and ask you to tell me which has the highest boiling point. If it's an alkane compared to the same haloalkane, the haloalkane would be higher. So these are your boiling points of haloalkanes here. This is 1 carbon chain, 2 carbon, 3 carbon, 4 carbon. You obviously do not need to memorize this slide. You don't need to know these numbers, but you'll notice As the halogens get larger in size, meaning they have more electrons, more surface area, the boiling point gets bigger. So like look at propane. Okay, so C3, propane. Regular propane has a boiling point, meaning it turns into a gas at negative 42 degrees Celsius. Well, the minute you add one fluorine, that boiling point jumps to negative 2.5. So that's much, much higher. When you add a chlorine instead of a fluorine, it goes to the positives. It's about 47. Bromine would make it 71, and iodine would make it 102. So again, you don't need to study or memorize this slide, but it's good. It does provide us with some good information. The alkane has the lowest boiling point. Then when I add fluorine, it gets a little higher. And as I add larger and larger halogens, and by larger, I mean, more electrons, the boiling point gets bigger. Okay, that's it. That's halogens. So that would be wink, 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 a good multiple choice. Comparing boiling points from alkanes to haloalkanes. This section is what I want to do today. So this section is the reason your lab is next week. Lab number 7, your last lab on campus. Okay, lab number 7 will cover alcohols and the properties of alcohols. So let's look at these. Section 6.2 is alcohols, so that would be anything with an OH. Phenols, that would be your aromatic compound with an alcohol, and thiols. Thiols, remember, are similar to alcohols in the sense that it's a functional group that has like a kind of a similar bonding structure, but instead of oxygen, it's sulfur. So alcohols are OH, phenols, you have your benzene ring with OH, and then thiols would be SH. All right, now let me check the chat before I get into this. Yeah, exactly. But now in chemistry, that's an interesting point. In chemistry, like the term alcohol doesn't mean what like we think when you hear it in everyday life. It's a different thing. So like in chemistry, alcohols are hundreds, thousands of different molecules. Anything with that functional group OH. So there's, anything. It could be methanol, ethanol, propanol, but then it can be even more complicated. So you could have like 2,2-dimethyl hexanol or something like that. I'd have to put a number in there as well, but you get the idea. So chemistry, we use terms a little differently. So well, back to naming. We haven't done naming in weeks, at least since chapter 4. So we're going to learn, I think this is about the last type of chemical that you will need to name. So we will look at naming alcohols. According to IUPAC, the International Union of Pure and Applied Chemistry, all you have to do, excuse me, when naming an alcohol is change the end to OL. So just like when we named an alkene or an alkyne, you would change the end to like ene or ine. With alcohols, you just change the ending to OL. So here are some basic rules, and you guys will be professionals at this. This is so simple, especially because we did naming in chapters 2, 3, and 4. This is going to be really easy for you. Okay, so rule number 1. You guys will notice some similarities here. The longest continuous chain of carbon atoms containing the alcohol, the OH, is taken as the parent compound. The chain is numbered nearest to the OH group. It's the exact same as when you do an alkene or an alkyne. Right? Remember that back in chapter 3? When you name an alkene, you take the longest carbon chain that has the double bond, you number it closest to the double bond, and that's it. That's your parent chain. So the same thing for alcohols. Now, this gets way, way, way more complicated when we start mixing functional groups, meaning if I gave you an alkene that had like an alcohol on it, it gets a little bit more complicated, but that's not in this course. We're keeping it simple. We're just naming like one thing. So when I give you this on your final, and we will do for the people who came in late next week, we have a full week of classes. Next week, we're going to do review for your final. And when you're seeing me do that review, you'll notice that like if I get you to name an alkene, it's just an alkene. If I get you to name an alcohol, it would just be an alcohol. I'm not going to include multiple functional groups. Keeps it a little simpler. Now, let me go through these rules and I'll just check the chat there. The number that indicates the position of the OH group is prefixed, just like naming an alkene. What I mean by prefix is I need to know the number of where the alcohol is, like the location. So, 2-propanol, or sorry, 2-propanol would be an alcohol. Propane is the base, so we have 3 carbons. And on the second carbon, we would have the OH group. If you have, substituents are named and numbered just like in alkanes. Remember what I mean by substituents. I mean like methyl groups, ethyl groups, propyl groups. And if you have more than one element present, more than one alcohol present, same as naming other compounds, we would use words like diol and triol. So di means 2, tri means 3. Whoops. You'll see me practice this now because it is pretty easy. Now let me read the chat first and then we'll practice this together. So pentanol. Okay, so we have 2 examples here. We have 2-pentanol and 3,4-dimethyl-2-pentanol. So a little bit more complicated. 2-pentanol is pretty straightforward. So let me pretend that the name isn't, let me pretend that the name isn't here. Okay, I want to count my longest carbon chain. Well, my longest carbon chain is here. Note that I don't start in the middle, like I'm not going to start at the OH. I'm going to start nearest to the OH. So then I number my elements, I number my carbons. So 1, 2, 3, 4, 5. Okay, so that's it. This is pentane. Okay, but because I have an alcohol functional group, so this is my functional group up here, this would actually be pentanol. But you can't just say pentanol because, where is the alcohol? Is it on the first carbon? Is it on the second? Is it on the third? It can't be on the fourth or fifth because then we would just renumber it. But this alcohol could be on the first, second, or third carbon. So I would say 2-pentanol to represent that it's attached to the 2. Okay, I have a very, very similar example over here. I'm going to start numbering from the right side and go backwards. So there's my longest carbon chain highlighted. So I would start numbering. I wouldn't start numbering here because I want a number closest to the alcohol. So 1, 2, 3, 4, 5. All right, so this would be, forget about the alcohol for now, this would be pentane. And I notice that on the third and the fourth carbon, I have methyl groups. So this would be obviously 3,4-dimethylpentane. But on the second carbon, again, I have an alcohol. So this would be 3,4-dimethyl-2-pentanol. If this looked the same, like if I had this example and I wrote it again and I put a double bond here, you would call this 3,4-dimethyl-2-pentene. So this is pretty easy, right? I hope this is easy. If any of you guys are confused or don't know what's happening, just let me know. But this is pretty straightforward. All right, let's look at a couple more, and then maybe I'll get you guys to do the 4 practice problems here. And then there's one last thing I want to do today because it's about your lab. I could do it on Monday as well, but I'm trying to get through as much as I can without going too fast so we can have review next week for your final. So yeah, here we go. Let me show you 2 more. I'll get you guys to practice 2 or 4, and then we're done. Or then we're almost done. Okay, so this one's a little bit more complicated. There's a few ways I feel that you could name this one on the left, and I would still be happy. This is obviously a cyclic chemical or a cyclic hydrocarbon. So this is cyclohexane. Now, we'll highlight my chain here. So I'm going to start at the alcohol, and I wouldn't go down. I would go left to the methyl group. Remember, you want your groups to be as low as possible. Okay, so let's number this guy. So again, 1, 2, 3 would be a mistake. I wouldn't want to do that. I would go this way, 2, 3, 4, 5, and 6. So 6 carbons in a ring, cyclohexane. All right, I'm going to start numbering at the alcohol, so that would be number 1. That means that the methyl is on the second carbon, so that would be 2-methyl, cyclohexane. But then, of course, I have I have an alcohol, so I need to change it from cyclohexane to cyclohexanol. Now, one thing. What about the number 1? Why didn't I put it there? And this is a question I got all the way back months ago, back in chapter 2. Why don't I put the 1 there? Well, it's really assumed that the 1 is there anyways. Like if this is a ring, I can start counting anywhere I want inside the ring. So I'm going to start counting it at the alcohol. So at the beginning, when I said that there are 2 answers or more answers I would accept here, I would also take this as an answer. 2-methyl, 1-cyclohexanol. That's okay too. But I mean, that's like, say, in math, if you wrote 1x or you just wrote x, your math instructor would probably prefer that you wrote x equals 3, not 1x equals 3. And I kind of feel the same. I would prefer that you didn't put the 1 in there, but it's not wrong, right? Just like in math, you're not wrong, you just don't need it. Okay, so let's look at one more, and then I'll get you guys to practice, and we are almost done for today. I started a little late today for 2 reasons. One, I had a meeting with another student about their labs. They've missed a lot of labs. And then when I came here, there was no students. So I did start a little bit later today than I wanted to. Okay, so first I'm going to go, I'm on this molecule on the right, the 1,3-butane diol. And then let's look at this one. So sorry, I just read the chat there. Okay, now for this one, I see a lot of confusion sometimes when students number something like this or name something like this. This is not part of the carbon chain. Like, okay, well, no, that's a bad thing to say. It's not a carbon at the end of this. Like, I don't count this where I'm highlighting as 1. It only joins the carbon chain here. So my carbon chain would look like this, and I'm going to number it. Oops. Get my pen. 1. Sorry, is that going to stay there now? 1, 2. Hold on, guys. My pen's being weird. 1, 2, 3, 4. There we go. So notice I started numbering the 1 here closest to the nearest alcohol. So this would be, well, first of all, this is 4 carbons. So this would be butane. But on the first and third carbons, I have functional groups. I have your alcohol functional group. So you would say 1,3-butane diol. Now, a little bit of spelling here. Normally, if we just had 1 alcohol, this would be butanol. right? I wouldn't put the E there. But because I'm calling this a diol, you keep the E. I am not that crazy when it comes to spelling. So if you guys, like, say on the test, you name this 1, 3, and when I say test, I obviously mean your final exam. This is fine too. It's not really correct. I can kind of explain this to you. And I don't know if I really need to, but it is curious. It is interesting. So if this was just one alcohol, so say it was 3-butanol. Well, how come we dropped the E in butanol, but we didn't drop the E in butane diol? It has to do in English or in IUPAC naming it, if anything, the difference between consonants and vowels. So imagine this one, the top one, if I didn't drop the E. So 3-butanol. I'm putting together here two vowels, which we don't really like to do in chemistry in naming. It's kind of like when you name something like carbon hex oxide. We don't say carbon hexaoxide. That's not really a chemical, by the way. I just kind of that was the first thing that came to my mind. But we don't say carbon hexane. Or sorry, carbon hexaoxide. We would drop the vowel so we don't put two vowels together. So the reason we drop the E is to eliminate having two vowels together. 3-butanol sounds a lot better than 3-butanol, right? 3-butanol, 3-butanol. I find the top one sounds better. But when you have a diol down here, you're not putting two consonants together. You're putting a consonant, or sorry, two vowels together. You're putting a consonant and a vowel together. So 1,3-butane diol does sound pretty good. At the end of the day, guys, I don't really care. If you put the E in or you don't, it doesn't affect me at all. So I'll take kind of either. But, if you guys were curious why sometimes there's an E and sometimes there's not, it's about vowels. Okay, so guys, I would love for you to try these two slides or these two answers. And here's what I'll do. Sorry, I just stopped screen sharing for a minute. I'm going to do this. This is going to look a little silly, but I'm going to share my screen here, and I'm going to share a new type of screen, the PowerPoint itself. And you can see on the left, I have slide 13 and 14 with the practice problems. I'm going to give you guys a couple minutes to do this. You could, with the sketching, you could sketch it on a piece of paper, but for the naming, you can enter the name in the chat if you want. And I'll be back in maybe 2, maybe 3 minutes with the answers to these. Okay, so good luck. Again, what I want you to do is I want you to do this one and this one, like both of these slides, I should say. Okay, I'll be back in 3 minutes with the answers. All right, so I'm recording again. Let's go. Okay, write the skeletal formula for this compound. Now, one thing I'll mention, guys, is on your final exam, I'll check that for you, Niam. We'll see how the second one is. But for your final exam, you will only be expected to draw skeletal formulas, basically. So I'm comfortable. I'm happy with you guys using skeletal. If you want to do structural formula, that's the one with all the carbon or hydrogens. You would be crazy, but you can totally do that if you want to. But I'm a skeletal man myself. So heptanol, first thing I would draw is heptane. So 1, 2, 3, 4, 5, 6, 7. So there's heptane. Always start with your parent. Draw the parent chain, meaning in number 3 or number 2 here, sorry, I'm going to draw cyclopentane. Ooh, not a very good cyclopentane, was it? When I was a university student, I was so good at drawing these because I drew them like all the time, like hundreds of times a week for assignments and practice, but not so good anymore. Okay, so let's look at the top one. On the second carbon, now I'm a left to right person, so I'm going to call carbon number 2 over here. So on your second carbon, I have your alcohol because this is heptanol. And on the third carbon, I have an ethyl group. 3-ethyl, 2-heptanol. Easy. In this one, I have 3-chlorocyclopentanol. So it's cyclo, meaning, I don't really, it doesn't matter where I put the OH, the alcohol, it's going to be number 1. All I need to do now is make sure when I put the chloro group there, that it's 2 carbons away. So it would be number 3. Yours might look different than mine because maybe you numbered it going the other way. I typically like to go personally left to right, and I'm a clockwise type of person. But I mean, I'm open-ended. It's pretty easy. Okay, let's check these 2 names, and then I'll introduce the next section, and we are done. Oh yeah, I like your fixed answer a lot better than I am, because for fluor chloride I don't like, but for chloro I do like. Okay, so let's do it. Now, I need to number the longest chain here. I'll go a little quick through this because we know this. We've been doing this for months. I need to do my longest chain. This one's drawn in a very stupid way. The only reason someone would draw a skeletal structure this way, and keep in mind I drew this, would be to trick you. Nobody would normally draw a carbon chain like this where the longest chain goes up, but you got to be careful sometimes. So what I mean is when you guys are doing questions, be careful. I'm not really the type of instructor that tries to trick anybody, but just be careful. Make sure you are counting your longest chain. So my parent here is obviously hexane. So this would be, of course, hexanol. But I notice on the third and the fourth, I have methyl groups. So this would be 3,4-dimethyl. And then 2-hexanol. I got my window open and I can hear a crazy jet above me. I don't know if you guys can hear that. If you're in the Duhale area or near Lusail, you might be able, or the Pearl, you might be able to hear that big crazy plane. All right. Cool. Okay, actually, Niam, let me check your answer first. 3,4-dimethyl 2-hexanol. Perfect. 10 out of 10. Okay, let's look at the other answer. Now, this one, this is a good one, good practice one. I'm going to highlight my chain. So ideally, I would like to start here for a few reasons. It keeps the chloro down as a low number, and I still start numbering my alcohols at the second carbon. Now, let me explain. Let me number this incorrectly with blue. So I'm going to use blue here. So I could go 1, 2, 3, 4. Notice that my alcohols are still on 2 and 3, but my chloro is on 4. So let me try this again in red. What if I go 1, 2, 3, 4? I like this a little better. My chloro is now back down to number 1. My alcohols are still 2 and 3. So I think this is better personally. And when I say I think this is better, this is the answer, according to IUPAC anyways. So we would have 1 chloro, then I would have 2, 3, oops. Remember, whenever you have numbers, you use hyphens. This would be butane or butane diol. Now, again, you keep the E. I don't care if you didn't put the E in there. It's really like, like if I was marking this on a final exam, I'm looking for the correct numbers. I want to see the word chloro. If there's a spelling error there, I don't really care, but I want to see chloro. I want to see bute, BUT, I'm looking for that because that means that there's 4, and I'd be looking for diol. So this would probably be worth 2 marks. You know, you'd get 0.5, 0.5, 0.5, 0.5, or maybe even 2.5 marks, because this would be worth 0.5 and then another 0.5. These are marks, by the way. So I'd give you a mark for the 1 and the chloro. I'd give you half a mark for your 2 and your 3, half a mark to see the word but, and then another half a mark to see diol. And I'm not concerned about little spelling mistakes, not at all. All right, let me check the time. I think I'll have time for just one more. Yeah, it's 1:12. This is perfect. So what I'll do, guys, is I'll introduce this section. We'll do a little bit more of this on Monday, and that will mean we will be perfectly ready for our lab on Tuesday. On Wednesday's class, so here's my plan. Okay, my plan is on Wednesday's class, we will do a little review, we will finish up chapter 6, whatever I need to finish on Wednesday, and then we will start review in that class. So on Wednesday, I'll finish up anything from chapter 6. You know, we might not finish everything, but I'll finish up what I think is important, and then we'll start review. And then Wednesday and Thursday next week, we can do review. Okay, so that brings me to the last part of today. We will talk more about this on Monday, but the idea here is you will have a lab on Tuesday about the properties of alcohols. We're going to look at boiling points, we'll talk about hydrogen bonding, and we'll look at solubility and acid and base properties. These are all things that you will look at in your lab on Tuesday. That's your last lab. I do apologize for having the lab in the last week of classes. It's just we didn't, because of lab 6 and the quarantine situation, and then because of the fact that I hadn't done this in class yet, I figured we would move it. But anyways, not a big deal. So on Monday's class, we'll look at hydrogen bonding, boiling points, solubility, and acid-base properties, and that'll get us ready for your lab on Tuesday. Okay, guys, that's it for me. If you have any questions, let me know. And thank you, Naim. I'm glad you do understand. It's been a weird semester. I hope, inshallah, next semester after, like, I hope there's a vaccine or something that happens in December or January. Anyway, so you guys have a good day. Have a good weekend, especially. Be safe, wear your masks, wash your hands, and I'll see you all next week. It's nice to see you. So I'll see you in the lab next week. That'll be fun. One last time. Perfect. Thanks, Saud. See you guys. Have a great weekend. Like I said, be safe, wash your hands, wear a mask.